features of normalization?
To eliminate redundancies in data, and then to
Remove
make sure
anomalies.
if all the
Dependencies.
dependencies make sense.
So to eliminate redundancy and to ensure that dependency makes sense, huh?
And remove anomalies as well.
Yeah, to remove anomalies. So I would like to say that, yeah, to organize the data in a logical format, to avoid redundancy, and finally to eliminate the different types of anomalies that exist in a relational database design, right? So like last class we studied about three types of anomalies, right? So can anyone explain what do you mean by update anomaly?
So when you have some data in the table, and if you want to update some value, if you have instead of separating the schemas into different tables, if you have it in the same table, if you want to update just one column, you have to update all the rows which have that value as in that particular column. If you have it as separate columns, if you update only that particular table, it would be enough for all the whole database. So that would be the updation anomaly.
Yeah, correct, Subramanian. But can you give an example?
For example, let's say the income or something of or the number of students in a course, if something it reduces, you wanna, yeah. So should I give with a table, or is it explain? Is it fine if I like explain?
Yeah, with respect to a table, if you can give some example with respect to a set of relations, I think it will be easy for us to visualize.
Okay, sir. So student, and then course. So we'll have that, and
Right.
Select student and class. Then if we update the student's number in the student table, it won't be updated in the class. But if it's normalized, then it will be updated automatically.
Right. So I will give you some better example. Right. A student, for example, we have student and department details put together, and department student table contains like student ID, student name, age of the student, maybe his contact details and so on. And department details contain department ID, department name, location of the department, and contact number, right? So when the contact number of the department changes, what happens is that if both the student table and the department details, student details are and the department details uh, are put together in a single relation, when the contact number of a department changes, right? So you need to update the contact number for all the attributes, right? So you need to update the contact number for all the records in the relation, student department relation. Whereas if you are going to have a student relation separately and department relation separately, I need to update the contact number of the department in only one record, and it will be reflected across all the other records once you perform a join operation, right? So this is the advantage of this is known as update anomaly, right? So instead of updating a single record, you are forced to update multiple records in a complex relation. So even if one record is left out, right? So the point in updating multiple records in a relation is that even if a single record is left out, what it happens like you have multiple copies of the you have different values for the same attribute, and it may lead to database inconsistency, right? So different values for an attribute will conflict, right? You have old contact number for one student, sorry, old contact number of department for one student, and new contact number of department for some other student, right? So even if one student is not updated, if one student's department contact number is not updated, it results in inconsistency of the database, and this is known as update anomaly. And we discuss something about insertion anomaly. So whenever you have a complex relation like this, it is not possible to insert the department details alone unless you have some student register for that particular department, right? So for example, now many institutions, they are starting some new course in artificial intelligence and data science, BTech in artificial intelligence and data science. Similarly, let us also assume that NIT Trichy also offers some course in BTech in data science, right? What happens? Initially, let us assume that we are going to enter the details of the department alone, and like the students are not admitted to that particular course. So it is not possible to add the department details into the student department relation unless some students are registered for the course artificial intelligence and data science, right? So whenever you need to enter the details about the department, you need to enter some dummy details about the student, uh, in the case of student department relation. So it results in inconsistency of the database, right? So this is known as insertion anomaly, right? uh, Similarly, deletion anomaly occurs like when a student registers for the particular course, when all the students who have registered for the particular course leaves the particular course or the department, the entire information about the department is lost, right? So this should not happen. So you need to go for normalization, where normalization you are going to break a complex relation into smaller relations. We are going to go for some schema refinement so that there will be no redundancy, there will be no anomalies like insertion anomaly, deletion anomaly, or update anomaly, right? So this is what we have discussed in the last class. So whenever we are going to break a complex relation into smaller fragmented relations, there are two types of decomposition that takes place. One is going to be known as lossy decomposition, and the other is known as lossless decomposition, right? So lossy decomposition means whenever you decompose a complex relation into a set of fragmented relations, it results in a loss of data, right? It is known as lossy decomposition. Whereas in the case of lossless decomposition, it is possible for us to decompose a complex relation into a set of fragmented relations without any loss of data, right? So the simple way to identify whether a decomposition is a lossy decomposition or it's a lossless decomposition is that you are going to perform the natural join of the decomposed fragmented relations. If the natural join of the decomposed fragmented relations gives you back the original relation, we say that it's going to be a lossless decomposition. Whereas if the decomposition of the fragmented relations does not gives you back the original relation, we say that it's going to be a lossy decomposition. So in today's class, let me show you some examples for checking how to check whether a decomposition is a lossy decomposition or lossless decomposition. We'll also work out with some problems to check whether a decomposition is lossy or lossless decomposition. And the next topic that we'll study in today's class is like we'll study whether dependency is preserved in a decomposition, right? So if there exists some dependency between attributes in a relation, in a base relation, the dependency should also be preserved in the fragmented relations. So that also will check it out, how to check it out, whether dependency is preserved in a uh, schema, fragmented schema, right? So if the two conditions are met, so if it is going to be a lossless decomposition, and if the dependency is preserved in the fragmented relation, then only we say that the decomposition is a valid decomposition, right? Right. So let me share you something.